So at this point, with our test on Friday, hopefully we are feeling comfortable and confident with performing, here we go, translations, where we slide a figure, left, right, up, down. Reflections, where we flip our figure across the y-axis or across the x-axis. And rotations, where we turn our figure around the origin either 90 degrees clockwise, 90 degrees counterclockwise, or 180 degrees in either direction. We're not going to talk about dilations, just these three right here. So we've learned how to do them. We've talked about the rules. Now we're going to, oh man, I skipped a page. Now we're going to combine them. Okay, we're going to perform a sequence of transformations on a shape in order. So let's look at this first one here. I've got triangle MNO. Who could tell me what are my coordinates for point M? Lola? -1, -2. Perfect. What about point N? Vanessa?
-4, -1.
Perfect. And how about point O? Yeah, Johnny?
-3 and -3.
Perfect. -3, -3. What am I going to put inside triangle MNO on my graph before I even start? A 1. Okay. The first transformation we're going to do is a 180 degree rotation around the origin. We all know how to do that. We take our slide, put it over our graph. It should be precisely the right size, hopefully. Right? What am I going to draw on my slide first, just to make sure you guys know what we're doing?
Plus.
A plus? Yep. Amari, what do I draw next?
Dots.
Dots at M, N, and O.
In front of you.
Right? And then I'm going to turn my slide how many times? Twice. Either direction, doesn't matter. Once, twice. Okay, I'm going to move my slide. Is that necessary? Seriously? That's funny? For real? Yeah. You need a marker? Okay, I'll grab you one. Okay, please stop talking. Guys, make sure you're focused. You know, who's not? Oh, is that marker work? Okay. Works for me. What am I going to put inside this new triangle?
2.
A 2. Everybody with me on that?
Yeah.
Okay, what are M prime's coordinates?
1 and 2.
1, comma 2. What are N prime's coordinates? 4 and 1. What about O prime? 3 and 3. Take a look at my pre-image coordinates compared to my first set of image coordinates. What did we do with each of those numbers, Lola?
All the signs switched and the numbers switched places.
So all the signs switched, and you said the numbers swapped places, so the 2 came to the front and the 1 went to the back?
Yeah.
Did it?
Wait, no.
No, just the sign. That's all right. Just the signs swapped. We followed the rule -x, comma, -y. Now I decided to take rotation rules off of the test just because A, we don't have time, and B, the slides you guys have shown a lot of success with, so I'm not going to make it more complicated than it needs to be.
Thank you.
But we can clearly see that all my coordinates just all became positive. If they started out as positive, they would have all became negative. We just flipped the sign. Okay? So there's my first image. But now I'm going to reflect across the x-axis. This is extremely important. I need everyone to listen to this. When I rotated triangle 1 and got triangle 2, triangle 1 no longer exists. Okay? Obviously, I can't erase it because it's printed on, but I need to consciously tell myself my original triangle does not exist. Okay, we talked about the bed frame analogy. When you move your bed to a new house, you take it apart piece by piece, put it back together. Your bed is not at the old house once you take it apart and move it to the new one. Same thing here. I took this shape, I rotated it over here. Even though I still see this, it's not actually there. So when I now go to reflect across the x-axis, should I take a look at triangle 1 or triangle 2 when I do that reflection? Triangle 2. Number 1 no longer exists. So I'm going to take triangle 2 and reflect that line, that triangle across this x-axis right here.
So is it M prime prime?
It'll be M prime prime or M double prime, N double prime, and O double prime. Do you guys remember how to do a reflection? Yeah? Anyone want to volunteer to walk me through it? What am I supposed to do? Yeah, Lola?
So on the first square, you're gonna count how many times or how many lines it takes to get to the x-axis and then reflect it on the other side.
That's right. Great explanation. I appreciate that. I'm going to start at M prime. I'm going to count how many boxes it takes to get to the line of reflection. How do I know what the line of reflection is? They say it in the question. My x-axis, M prime, is 2 spaces away. So how much further am I going to go past the x-axis? 2 more spaces. 1, 2. What am I going to label this new point as?
3.
The point.
M prime prime.
M double prime or M prime prime. Like I said, primes are like rings on a tree. Anytime I do another transformation, I just add another little notch up at the top. How far away is N prime from my x-axis? 1 box. So I'm going to go 1 box further for N double prime. What about O prime? How far away is O prime from the x-axis? 3. 1, 2, 3. I'm going to go 1, 2, 3 more. O double prime. What am I going to write inside this triangle now? 3. So if I'm looking at this, right, let's say there's a question on the test that looks like this, and it says, describe the sequence of transformations. You say, okay, well, I started in quadrant 3, I rotated 180 degrees, and then I reflected across the x, because I'm just following the number order, 1, 2, 3. If I don't have 1, 2, 3, I don't know what the order of transformations I did is. You guys understand that? Yeah? Okay. So this is what we get. What are M double prime's coordinates? This little blue guy right here. Positive 1, negative 2. What about N double prime? Positive 4, negative 1. And O double prime? Positive 3, negative 3. So again, my original coordinates, which were in black, no longer exist. What happened from my pink prime coordinates to my blue double prime coordinates? What changed? The y values all flipped signs. My x's stayed the same, but my y's flipped signs. So this rule we could say is x, comma, negative y. Right? Nothing flipped about my x's, but my y's all went from positives back to negatives. Is that making sense? Cool. Again, it's really nothing different. It's just putting things together and making sure, A, that we go in order, and B, that we never ever use an old triangle when doing a new transformation. All right? Let's look at this second one here. Who can tell me what are my coordinates for x prime? X prime's coordinates. Johnny? Oh, sorry. X's coordinates. My bad. 1, 4. Perfect. What about y? 4, 4. And z? Yeah, Vanessa?
4, 2.
4, 2. All right? Yes.
I look at a big top.
Sure. Just grab a Kleenex right behind you. All right, the first thing I'm going to do here is translate. What's another word for translate again? Starts with an S.
Move it, slide it.
Slide it.
One side.
That's right. We're going to slide it left, right, up, down, depending on what my rule says. So this rule here says x minus 5, y minus 1. What does x minus 5 tell me I'm going to do with this shape? What direction does that tell me I'm going to go? Left, right, up, or down? I'm going to go to the left. Give me a thumbs up if you agree with that. X minus 5 tells me I'm going left 5. How do you know we're not going down 5?
Because it's not with the Y.
That's right. X is my left and right movement. So if I see X plus, I know it's right. X minus, we're going left. What about Y minus 1? What does that tell me I'm doing? Going down 1. All right? So if I start at point X, I'm going to follow these directions. I'm going to go left 5, 1, 2, 3, 4, 5, and down 1. X prime. Okay, throw a 1 in my original triangle. I'm going to have a 2 here in a second. What are X prime's coordinates, though?
-4.
-4, +3. Before we do our next 2 points, look at my coordinates here. How do I get from 1 to -4? Right, think about when we did slope. We had it in a table. If I did a little arrow, how would I get from 1 to -4? Subtracting how much?
4. I mean,
From 1 to -4?
You have to go down.
We're subtracting what? 5.
5.
How do I get from 4 to 3?
-1.
I'm minusing 1. Where have I seen a -5 and a -1 before?
On the translation.
Right here in the translation rule. So if I forget, my directions and my counting and all that, I can literally just take this coordinate, subtract 5. So for y prime, right? I've got 4, 4. Well, what's 4 minus 5? -1, thank you. And what's 4 minus 1?
3.
3. Let's check that out and see if it works. -1, +3, y prime. Is that where I would have been if I counted on my graph? 1, 2, 3, 4, 5 to the left, 1 down. So I can do this either way. If you like counting on the graph, visually that makes more sense, then do that. But you can always use the rule to just get the coordinates and then plot them that way. All right, Z, I'm going 5 to the left. 1, 2, 3, 4, 5, 1 down. Boom. There's Z prime. I'm going to connect these all up. What am I going to put inside this purple triangle? 2. And what are Z prime's coordinates?
Z prime. Oh, wait.
Coordinates, -1, 1. Right? Everyone cool on that translation? I know it's been a while, but that's the easiest one. We're just counting. Okay? What I'm going to do now is rotate 90 degrees counterclockwise around the origin. Which triangle am I going to trace? Am I going to trace the black triangle or the purple triangle?
Purple.
The purple. Why aren't I going to trace the black one?
Because it's the original.
It's my original shape. It does not exist. It's gone. Good morning, Muhammad. It's gone. It doesn't exist. I'm going to trace my purple triangle. There's Z, Y, and X. All right? Counterclockwise, after notes. Counterclockwise is turning to the left or turning to the right? Turning over to the left. So I'm going to do a little arrow here, going over to the left, and just follow that arrow down to quadrant 3. Now, if for whatever reason you forget which way is left and which way is right, and you turn like this, if I see my 2 triangles overlapping each other, I know that I've done something wrong. Okay, there should never be any triangles overlapping each other like that. So you know, okay, I've got to go this direction, and I land right here. Okay, so Z double prime is right there. y double prime is right there, and x double prime is right there. Connect those up. What am I going to put inside this green triangle now?
3.
The number 3. Take a moment, copy down or write down what my double prime coordinates are in green. Where is x double prime? What are my coordinates for x double prime? Negative 3, negative 4. Good. What about y double prime? Negative 3, negative 1. Thank you. And z double prime? Negative 1, negative 1. What do we notice about my coordinates from my purple triangle to my green triangle? Yeah, Lola?
The x values were all negative, and then on the second round, both numbers are negative.
That's right. So in my purple, my prime, right, triangle number 2, I've got negative x's, positive y's. Over here, I've got negative x's and negative y's. So something flipped signs. What also happened to the order of my x and my y? It flipped. It swapped around. My x value went to the back, unchanged, and my y value flipped signs and came to the front. Give me a thumbs up if you see what I mean when I say that. I'll say it again. My x value stayed the same and went to the back. My y value flipped signs, became negative, and went to the front. So the rule here for this would be negative y, comma, x. And this is why I said we're not going to learn rotation rules, because that one can be really confusing. If you see it and you get it, that's great. It'll make your life easier, especially when checking your work. But I want you guys to focus on using the slide for right now. Okay? Questions I can answer about that one? Okay. And then tomorrow we'll throw in a third transformation that's going to bring this guy over here so that we have one triangle in each quadrant by the end of it. All right?